Flexible cord installation is generally permitted by the National Electrical Code, referred to as the NEC, under specific conditions. Firstly, the flexible cord must be listed for the intended application and location. Secondly, the flexible cord must be protected from physical damage by being installed in a raceway or other approved means. Now let's discuss recommendations for flexible cord and alternative suggestions. Firstly, let's talk about cord. This is a durable oil-resistant cord suitable for use in damp or wet locations. Secondly, there's SJO cord. This is a heavy-duty cord with a jacket resistant to moisture, abrasions, and sunlight. Thirdly, there's SD cord. This is a flexible cord designed for temporary lighting installations. Now let's explore some alternative suggestions. Firstly, we can consider EMT conduit. EMT conduit is a lightweight metal conduit that can be installed quickly and easily. It provides better protection for the flexible cord than a raceway. Secondly, there's rigid polyvinyl chloride or PVC conduit. This is a durable and watertight conduit suitable for use in both indoor and outdoor environments. Thirdly, there's flexible non-metallic conduit or FMC. This is a flexible and corrosion-resistant conduit that is easy to install and can follow irregular pathways. Other considerations to keep in mind are the following. Firstly, use a transformer with a weatherproof enclosure to protect it from the elements. Secondly, seal all conduit and junction box openings with appropriate weatherproof fittings. Thirdly, consider using a 2-wire cable, such as 18.2, for the secondary side to avoid the need for multiple conductors. Fourthly, if using plastic connectors, ensure they are rated for outdoor use and provide a waterproof connection. Always consult with a qualified electrician or the NEC for specific guidance based on specific installation conditions. When dealing with electrical installations, understanding the National Electrical Code is paramount. The NEC provides comprehensive guidelines to ensure safety and compliance in various electrical projects. Flexible cords, while convenient, have specific regulations governing their use. According to the NEC, flexible cords are permitted under certain conditions, focusing primarily on the cord's listing for its intended use and the necessity for physical protection. The listing ensures the cord is manufactured to meet specific safety standards for its designated environment, whether it's indoor, outdoor, wet, or dry locations. Physical protection is crucial to prevent damage to the cord's insulation and conductors, which can lead to electrical hazards such as shorts, shocks, or fires. This protection typically involves installing the cord within a raceway or another approved enclosure that shields it from mechanical stress, abrasion, or environmental factors. When selecting a flexible cord, several options cater to different environmental and operational demands. Cord, with its oil-resistant jacket, is ideal for settings where exposure to oils, lubricants, or other chemicals is likely. This makes it a robust choice for industrial environments or outdoor applications where such substances might be present. SJO cord, known for its heavy-duty construction, offers resistance to moisture, abrasions, and sunlight. This cord is well suited for outdoor use, temporary power solutions, and construction sites where the cord is subjected to harsh conditions. SD cord, designed for temporary lighting installations, provides flexibility and durability for short-term setups. It's commonly used for holiday lighting, event lighting, and temporary work lights, but it's essential to ensure it's rated for the specific environmental conditions it will encounter. While flexible cords offer convenience, there are situations where alternative wiring methods provide superior protection and longevity. EMT conduit, a lightweight metal conduit, is a popular choice for its ease of installation and robust protection against physical damage. EMT conduit can be quickly cut, bent, and joined using fittings, making it a versatile option for various applications. It offers excellent protection against impacts, crushing, and abrasion, ensuring the enclosed conductors remain safe and functional. Rigid PVC conduit is another viable alternative, particularly in environments where corrosion is a concern. PVC conduit is resistant to water, chemicals, and other corrosive substances, making it ideal for underground installations, agricultural settings, and industrial plants where exposure to corrosive materials is common. Its durability and resistance to environmental factors ensure long-term reliability and minimal maintenance. Flexible non-metallic conduit, or FMC, provides a balance of flexibility and protection. FMC is easy to install in tight spaces and irregular pathways, making it suitable for retrofits, renovations, and applications where conduit needs to navigate around obstacles. While it offers less physical protection than EMT or rigid PVC conduit, it still provides a significant upgrade over exposed flexible cords. Several other factors merit consideration to ensure a safe and reliable electrical installation. Using a transformer with a weatherproof enclosure is crucial for outdoor lighting systems to protect against rain, snow, and other environmental elements. Weatherproof enclosures are designed to prevent water ingress, which can cause electrical shorts, corrosion, and equipment failure. Properly sealing all conduit and junction box openings with weatherproof fittings is equally important to maintain a watertight system. These fittings prevent moisture from entering the electrical system, ensuring the integrity of connections and preventing corrosion. When wiring low-voltage lighting systems, using a 2-wire cable like 18.2 can simplify the installation and reduce the number of conductors required. This cable consists of 2 insulated conductors within a single jacket, making it easier to manage and terminate connections. Ensure the cable is rated for the intended voltage and environmental conditions. For plastic connectors, choosing those rated for outdoor use and providing a waterproof connection is essential. Outdoor rated connectors are designed to withstand exposure to moisture, UV radiation, and temperature fluctuations, ensuring a reliable and long-lasting connection. Waterproof connections prevent water from entering the connector, which can cause corrosion, shorts, and electrical failures. To comply with the NEC, it's crucial to follow specific guidelines related to flexible cord installations. NEC Article 400 covers the use, construction, and ampacity of flexible cords and cables. It outlines the conditions under which flexible cords are permitted, as well as restrictions on their use. Flexible cords should not be used as a substitute for the fixed wiring of a structure. They should not be run through walls, ceilings, or floors, and they should not be concealed behind building finishes. They are primarily intended for connecting portable appliances, equipment, and lighting fixtures to a power source. The NEC also specifies the allowable ampacity of flexible cords based on their conductor size and insulation type. It's essential to select a cord with an ampacity rating sufficient to handle the load it will carry to prevent overheating and potential fire hazards. Additionally, the NEC requires that flexible cords be protected from physical damage, as mentioned earlier. This can be achieved through the use of raceways, enclosures, or other approved means. The type of protection required will depend on the specific application and environmental conditions. Consulting with a qualified electrician or electrical inspector is always recommended to ensure compliance with the NEC and local codes. They can provide valuable guidance on selecting the appropriate wiring methods, protection measures, and installation techniques for your specific project. Understanding and adhering to the NEC guidelines will ensure a safe, reliable, and compliant electrical installation. For example, NEC Section 400.8 details the permitted and prohibited uses of flexible cords and cables. It clearly states situations where flexible cords are not allowed, such as where they are run through holes in walls, structural ceilings, suspended ceilings, or floors, where they are run through doorways, windows, or similar openings, where they are attached to building surfaces, or where they are concealed behind building walls, structural ceilings, or floors. These restrictions aim to prevent damage to the cord's insulation and conductors, which could lead to electrical hazards. NEC Section 400.7 outlines the permitted uses of flexible cords and cables, which include pendant or portable luminaires, connection of portable appliances, wiring of equipment where flexibility is necessary, and temporary wiring for specific applications. It's crucial to ensure that the use of flexible cord aligns with these permitted applications to comply with the NEC. NEC Table 400.5 provides ampacity ratings for flexible cords and cables based on their conductor size and insulation type. This table is essential for selecting the appropriate cord size to handle the electrical load safely. The ampacity rating indicates the maximum current the cord can carry without overheating, and it's crucial to choose a cord with a rating that meets or exceeds the load requirements. Overloading a flexible cord can lead to insulation breakdown, conductor damage, and potential fire hazards. NEC Section 300.11 addresses securing and supporting wiring methods, including flexible cords and cables. It requires that wiring be securely fastened in place to prevent strain on connections and protect against physical damage. Flexible cords and cables should be supported at intervals that ensure they are not subjected to excessive tension or abrasion. Proper support helps maintain the integrity of the wiring system and prevents potential hazards. NEC Section 314.17b covers the use of flexible cords and cables for connecting devices within enclosures, such as junction boxes. It specifies the requirements for protecting the cord at the point where it enters the enclosure, typically through the use of strain relief fittings. These fittings prevent tension on the cord from being transmitted to the connections inside the enclosure, ensuring a secure and reliable connection. NEC Section 590 addresses temporary wiring requirements, which often involve the use of flexible cords and cables. It specifies the conditions under which temporary wiring is permitted, as well as additional safety measures to protect against hazards. Temporary wiring installations must be regularly inspected and maintained to ensure their continued safety and compliance. NEC Article 520 covers wiring methods for theatres, motion picture and television studios, and similar locations where flexible cords and cables are commonly used for connecting lighting equipment and other portable devices. It outlines specific requirements for the type of cord used, its ampacity rating, and the methods for protecting it from physical damage. In addition to the NEC, local codes and regulations may impose additional requirements or restrictions on the use of flexible cords and cables. It's crucial to consult with a local electrical authority to ensure compliance with all applicable codes and regulations. Obtaining the necessary permits and inspections is also essential to ensure that the electrical installation meets the required safety standards. To select the appropriate flexible cord, several factors should be considered. Firstly, the voltage and current requirements of the connected equipment should be determined to ensure the cord's ampacity rating is sufficient. Secondly, the environmental conditions in which the cord will be used should be assessed to determine the appropriate insulation type and resistance to moisture, chemicals, and abrasion. Thirdly, the length of the cord should be minimized to reduce voltage drop and ensure efficient power delivery. Fourthly, the flexibility and durability of the cord should be considered to ensure it can withstand the intended use and movement. Fifthly, the listing and certification of the cord should be verified to ensure it meets the required safety standards. The installation of flexible cord should be performed by qualified personnel who are familiar with the NEC and local codes. The cord should be carefully routed to avoid sharp bends, kinks, and abrasion. Connections should be made using approved connectors and fittings, and strain relief should be provided to prevent tension on the connections. The installation should be inspected and tested to ensure it meets the required safety standards. Maintenance of flexible cords is essential to ensure their continued safety and reliability. The cord should be regularly inspected for signs of damage, such as cuts, cracks, and abrasion. Damaged cords should be replaced immediately to prevent electrical hazards. Connections should be checked for tightness and corrosion, and any loose or corroded connections should be repaired or replaced. The cord should be kept clean and free of debris to prevent overheating and insulation breakdown. The safe and compliant use of flexible cords requires a thorough understanding of the NEC, local codes, and best practices. By following these guidelines, electrical professionals can ensure that flexible cords are used safely and effectively, minimizing the risk of electrical hazards and ensuring the reliable operation of connected equipment. Remember, consulting with a qualified electrician or electrical inspector is always recommended for specific guidance on your electrical project.